Imagine the world in which hoverboats, supersonic trains, bionic chips, hovering cars, and small quantum computers are reality. Hi, welcome to Nerd Castle. My name is Sir Simrat, and today I'll be talking about social and environmental impacts of superconductors. Before we delve into how superconductors affect our social and ecological needs, let's talk about the science behind superconductors. Superconductors are made of materials like aluminum, mercury, and other compounds belonging to copper-8 family like yttrium barium copper oxide and HgBa2Ca2Cu3O8. These metals and compounds behave like superconductors when their temperature hits critical phase, which is closer to absolute zero, that is, negative 273.15 Celsius. Like aluminum has critical temperature at 1.2 kelvins and mercury has critical temperature of 4.2 kelvins. When these temperature goes to critical phase, the resistance goes to absolute zero. Now, let's talk about regular metals. When we pass electrons from regular metal, we lose some energy in form of heat. This is because when electrons pass through regular metal at room temperatures, atoms inside metal have kinetic energy. So, when electrons are passing through the metal, they bump into vibrating atoms, therefore losing some energy. But this phenomena can take place when temperatures are closer to absolute zero. This happens because atoms have no kinetic energy left since there is no heat around them, so electrons in a metal could flow freely. The other effect of zero resistance is the expulsion of magnetic field from the core of the material, and this happens because superconductors circulate current inside them because there is no resistance, so magnetic field flow outside rather than making a loop. But as we know, nothing is perfect. Due to impurities in material, some strands of magnetic field lines are left inside superconductor. Because this is a quantum phenomenon, these strands come in distinct quantum values and like to move. But we discussed earlier that superconductors likes to be at a stable state and not lose any energy. To get this stable state, new phenomena happens that is called quantum locking. Due to this quantum locking, new physical properties occur when superconductors are introduced to permanent magnets. This new physical phenomena is known as quantum levitation. In this quantum levitation, when superconductor is cooled to critical temperature and introduced to external magnetic field, like permanent magnet, it will hover and it will stay in the same locked position that it started off with to the permanent magnet. That means that there is not only a repulsion of two magnetic fields, but there is overlapping and locking of two magnetic fields. Now let's talk about the topics that we first started off with, social and environmental impacts of superconductors. As I alluded to hoverboats, supersonic trains, bionic chips, hovering cars, and small quantum computers at the beginning of this video, all of these technologies are possible by superconductors. The proof of this could be seen in the video produced by Lexus in 2014, which shows a levitating hoverboard in one of their commercials. In this commercial, they use superconductors on a strip of embedded high-power neodymium magnets. Of superconductors could be seen in the research done by Stanford and the University of Sherbrooke, where they levitated model trains and proved the concept that levitating trains could be done. This is also good for the environment because now we'll be using less energy since there are no contact points with the metal. Therefore, friction should go to almost zero. Once our materials scientists, chemists, and physicists develop high-temperature superconductor, we could make bionic chips and small quantum computers possible. Because now we'll be inputting and outputting more information than regular wires. If the microchips are made up of high-temperature superconductors, they'll need less energy to function since there is no resistance. If there is no resistance, it'll give away no heat. So it'll be safer for us to put microchips in someone's body. Last and the most exciting function of superconductor is to use them in electrical grids. Almost 20% of energy we produce is dissipated from electrical wires in form of heat. If we use superconductors in form of wires and storage devices, energy loss could go to 8 to 10%, therefore significantly affecting Earth's economy and ecology in positive manner. My name is Sir Simran and thank you for listening to Nerd Castle.